We are discussing GATE Physics 2016 Quantum Mechanics problem. Which of the following transition is not allowed in the case of an atom according to electric dipole radiation selection rule? Solution. This selection rule for electric dipole radiation is delta L is equals to plus minus 1. Thus, the transition S to 1s is not allowed as delta L is equals to 0. Thus, option A is our correct answer. Which of the following operator is Hermitian? Let us check it. Solution. The kinetic the particle in terms of operator is expressed as twice m h cut I square into d square by lux square. Thus, operator d square by del x square is Hermitian. Thus, option B is correct for this problem. The scattering of a particle by a potential can be analyzed by Born approximation. In particular, if the scattered wave is replaced by an appropriate plane wave, the corresponding Born approximation is known as the first Born approximation. Such approximation is valid for solution. We have to determine the condition under which Born approximation is valid. The first Born's approximation is valid for particle having large incident energies and weak scattering potentials. Thus, our option A is correct answer. If S1 and S2 are the spin operator of the two electrons of helium atom, the value of expectation value of S1 dot S2 for the ground state is solution. Spin S can be written as S1 plus S2 implies S dot S can be written as S1 plus S2 dot S1 plus S2 dot. So we can write it down S square to S1 square plus S2 square plus 2 S1 dot S2. Thus, the expectation value of S1 dot S2 can be written as 1 by 2 S square minus S1 square minus S2 square. Now, further, expectation value of S square is S into S plus 1 H cross square. Expectation value of S1 square is S1 into S11 plus 1 H cross square. Similarly, expectation value of S2 square is S2 plus 1. Further, also S1 equals to S2 equals to half. S can take value 0 and 1. S is equals to 0 corresponds to singlet state and the ground state is given by singlet state S is equals to 0 only. Thus, the value of del S1 del S2 for S is equals to 0 and S1 S2 is equals to 1 by 2 is S1 S2 1 by 2 S into S plus 1. I have taken H square out minus S1 plus 1 into S1 minus S2 plus 1 into S2 can be written as H square by 2 0 into 0 plus 1 minus 1 by 2 into plus 1 minus 1 by 2 into 1 by 2 plus 1, that is H square by 2 minus 3 by 4 minus 3 by 4 is result into minus 3 by 4 H square. So the ground state energy, the value of S1 S2 for the ground state is minus 3 by 4 H square. That is option B is correct. Sigma x, sigma y and sigma z are the Polish matrix. The expression 2 sigma x, sigma y plus sigma y, sigma x is equals to. Solution. The Polish matrix matrices are defined as sigma x is equals to 0, 1, 1, 0, y is equals to 0, I, 0, sigma z is equals to 1, 0, 0, minus 1. The value, the expression 2 sigma x, sigma y plus sigma y, sigma x is equals to 2 sigma x, sigma y plus sigma y, sigma x is equals to 2 into 0, 1, 1, 0, 0 minus I, 0 plus 0, minus I 0 0 1 1 0. It is equals to I 1 0 0 minus 1 equals to I sigma z. That is option C is correct. If x and p are the x component of the position and momentum operator of a particle respectively, the commutator of x square and p square. Solution. We have x square, p square. Now write it like this. We would be having it x p square plus x p square into x. Now write operating on this, so we would be having xp plus x into xp into p plus p xp x plus xp into px. So we would be having it 2IH cross xp plus px, where we have used xp equals to IH cross. So option D is correct. Let Lm be the simultaneous eigenstate of L square and Lz, where L is the angular momentum operator with Cartesian component Lx, Ly, Lz, and L is the angular momentum quantum number and m is the azimuthal quantum number. The value of 10 Lx plus I Ly 11 expectation value of this term is. We have to determine the value for this term. Solution. We know that L plus operator L plus is defined as Lx plus ILy. So the value of 1, 0 Lx plus ILy 1, minus 1 is equals to 1, 0 L plus 1, minus 1, that is equals to 1, 0 root 2 cross h. 1, 0 is equals to root 2 cross h, where we have used L plus 1 minus 1 is equals to h cross root over 1 minus 1 into 1 minus 1 plus 1 into 1 minus 1 plus 1, which is equals to root 2 h cross 1, 0. Thus our answer for this problem is option C, that is root 2 h cross. For the parity operator, which of the following statement is not true? Solution. Parity operator P does not satisfy the relation P square is equals to minus P. That is option B. Consider an elastic scattering of particle at L is equals to 0 state. If the corresponding phase shift delta naught is 90, the magnitude of incident wave vector is equal to root 2 pi. Then fermion. Then the total scattering cross section in the unit of Fermi square is. Solution. We have delta naught is equals to 90 degree or pi by 2. K is equals to root 2 pi fermion was the total scattering cross section in terms of Fermi meter square is. Sigma is equals to 4 pi k square sin square delta 0, which is equals to 4 pi by 2 pi Fermi square, that is 2 Fermi square. So answer is 2. A hydrogen atom is in its ground state. In the presence of uniform electric field E0Z, the leading order change in the energy is proportional to e to the power n. The value of exponent of n is. When an atom is placed in the presence of external electric field, there occurs a shift in the energy level of atom. Such phenomena is referred as Stark effect. However, for hydrogen atom, the Stark effect is not observed for the ground state wave function of the hydrogen atom. For the first excited state, the quadratic Stark effect takes place with the variation in the energy as E square. Thus, the exponent is equal to 2. So answer for this problem is 2. A two-dimensional square rigid box of Seidel contains 6 non-interacting electrons at T is equals to 0 K. The mass of electron is N. The ground state energy of the system of electrons in unit of pi square h square by 2 ml square is. Solution. Since electrons are fermions, that means each state can occupy 2 electrons. The distribution of electron in energy eigenstates is shown below. The energy of two-dimensional square box of side is given by is equals to nx square plus ny square pi square h square by 2 ml square. So for ground state is 1, 1. Excited state is 2, 1 into 1, 2. And next excited state is 2, 2. So in the ground state, in the state 1, 1, 2 electron can occupy. There are 2 states for the energy 2, 1, 1, 2. That means each of the state can occupy 2 electrons. So that is the ground state. Now the ground state energy for the system is E0 is equals to 2 into 1 square plus 1 square into pi square h square by 2 ml square plus 2 into 1 square plus 2 square pi square h square by 2 ml square plus 2 into 2 square plus 1 square pi square h square by 2 ml square. So the result is 24 pi square h square by 2 ml square. So our answer for this problem is 24. The state of a system is given by psi is equals to 515253, where 515253 forms an orthonormal set. The probability of finding the system in the state phi 2 is. We have psi a phi 1 plus 2 phi 2 plus 3 phi 3, where normalization constant the value a is obtained from normalization condition. that is psi dot psi is equals to a square phi 1 phi plus 4 phi 2 phi 2 plus 9 phi 3 phi 3 equals to a square equals to 1 plus 4 plus 9 equals to 1 implies a is equals to 1 by root 14. The normalized wave function is given by psi is equals to 1 by root 14 phi 1 plus 2 by root 14 phi 2 plus 3 by root 14 phi 3. The probability of finding particle in state phi 2 is given by P of phi 2 equals to phi 2 dot psi mod square, that is 2 by root 14 phi 2 dot square, that is 4 by 14 0.28. Thus our answer is 0.28. A particle of mass m, energy E, is moving in the positive x direction, is incident on a step potential at x is equals to 0 as indicated in the figure. The height of the potential is V0 and where V0 is greater than the energy of the particle. At x is equals to x0 where x0 is greater than 0, the probability of finding the electron is 1 by E times the probability of finding it at x is equals to 0. The value of x0 is, we have to determine the value of x0 at which the probability of finding the particle at distance x0 0 becomes 1 by t times. Now let initially the particle that is a point x0, that is x0 0. This is region first, this is region second. Now case we are dealing with E is less than V0. The wave function for the particle in region x less than 0 is psi 1x equals to a e to the power I k1x plus b e to the power minus I instead of k1x. The wave function of the particle in region x greater than 0 is psi 2x is equals to c e to the power minus alpha x. The relation between coefficient A, B and C are given by B by A is equals to K1 minus I alpha to K1 plus I alpha is equals to e to the power minus 2I phi, implies mod P by A is equals to 1. That is, reflection coefficients is equals to 1. C by A is equals to 2K1 into K1 plus I alpha. This can be written as 2 cos phi e to the power minus I phi. The wave function in region first can be rearranged as psi1 x is equals to A e to the power I k1x plus B e to the power minus I k1x can be written as e to the power I k1x plus e to the power minus I 2 phi plus k1x. The probability of finding the particle in region first is P1x is equals to psi star x into psi x equals to 2 plus e to the power I 2 phi plus 2 k1x plus e to the power minus I 2 phi plus 2 k1x, which can be written as 2 plus 2 cos 2 k1x plus 2 phi. Similarly, the wave function in the region x greater than 0 is rearranged as psi 2x equals to c e to the power minus alpha x, which can be represented as 2 cos phi to the power minus I phi. That means the probability of finding particle in region x greater than 0 is in both region where we have used age equals to 1 in both the cases, the probability of finding the particle in both region at x is equals to 0 is P2 x is equals to 0 equals to P1 x is equals to 0 equals to P into cos square phi. Thus, equation 1 reduces to P2 x is equals to P2 x is equals to 0 per minus 2 alpha x, which is equals to P2 x is equals to 0 to e to the power minus 2 alpha x, or P2 x is equals to 0 equals to 8 minus 1 is equals to e to the power minus 2 alpha x, implies x is equals to 1 by 2 alpha. Thus, correct option for this question is 1 by 2 alpha, option C.